Welcome to another video program with R Studio. Today I'm going to present a logistic regression model. This data has been provided by one of the viewers, and he requested me to help him to do the analysis. If you haven't previously viewed my video about what is R and what is R Studio, I request you to go to the previous videos to understand how we can use R and R Studio and how we can import the data. Today I'm using the data set that is provided from one of the friend. This is the data set, and if you want to analyze this data set, just a minute, it's loading. It is taking few times. Okay, that is the data set I get. Okay, I have imported this data set. Here you can see the data set has the sex, age, education, and marital status, and family size, and he has y variables is interest variable, which is a dummy variable having the value 1 or 0. It is birth control or not control. I'm not sure exactly, but this is the dependent variable, and rest are independent variable. So let's see the structure of the data first. For the structure, we use the str function. The file name is chora2, this one, and this is the structure. For the sex, it is also a numeric data. Actually, it should be the factorial. There's the dummy variable 1 or 0, and we have 44 observations. For the age, we have also the 44 observations, and you can see the first few variables, the few observations here. Then we have the education. It is also a numeric variables. Marital status, it is also a numerical variable, but we have to convert it to the factorial variable first. Then the family size, it is also a numeric variables, and for the y variables we got as a character, so we have to convert it to the non-character form. Before that, okay, let's convert the y variable to the first numeric, then we will convert it as a factorial. Okay, so for the data set, this one, we have y variable, and we are trying to convert it first as a numeric, then we will convert it as factorial. As the numeric for the chora, this is the data set, and we will assign y. Okay, let's check again about the structure of the data set. Now it became numeric. Okay, before going to the logistic analysis, let's first check about the linear OLS method for the analysis. Then we will discuss why we have to go for the logistic regression or generalized linear model for this kind of data set. Let's have a model 1, that is 1, M1. It is just we are naming a name of the model, and we are trying to run first of all the linear regression model. There's LM, and we are providing y as the dependent variables, and rest of the variables as the independent variables. We can also use just like this function, and we can provide the data set as a 2. It is essentially saying we are trying to use all variables except y as a independent variables. Let's check the result first. We have a model 1, that's the linear model. Let's summarize the M1 model, which is a linear model. This is the linear model. And let's check the plot M1. We can see the plot here. Here you can see the observations are quite apart from the predicted line. For the normal QQ plot, it is also a linear. Neither the scale location is linear. Everything is not quite well with the linear model. Basically, for the value 0, 1, for the interest value, if there is a dummy variable like the 0, 1 or the categorical variable 0, 1, we cannot use the linear model as we learn right now, because the value, dependent value, have just 0 or 1, but in the extreme case, the predicted value might be more than 1 or less than 0. So instead of that, we just change the model from the linear model to the generalized linear model. So for doing that, let's change our numeric value to the categorical value. That is a factorial value. Here is the y. We have to change it as a factor to y. Okay, we have to also change a factor 6 into the factor also. It is 0, 1, or male female factor 6. For the marital status, we also change it as a factor. Marital status is factor. Okay, so let's see the structure again. Now see here we have y variables, that's our interest variable, or the dependent variable as a factor of the two factors, 0 or 1. And we have the marital status factor, it is also the 1, 2, that is married or not married. Education is numeric, age is numeric, and the sex is also a factor, is 1 or 2, male or female. Okay, let's have a summary of the data. This is a summary of the data frame we have. We have the sex 1 for 42 observations and 2 for just 2 observations. It's a highly biased, I think. For the age, minimum value is 22 years old and maximum value 80 years old. Then the first quarter is 38. For the median value is 43, and the mean is also 43. For the third quarter value is 48. For education, we have the minimum value 1. There is I think 1 year out of 1 class, and the maximum value is 4. There's the 4 class. There's some kind of the categorization, I don't know exactly. For the marital status, 1 is unmarried, I think. We have the 10 observations, and the 2 is married, 1 and 34 observations. For the family size, we have the 3 at minimum and the 14 as maximum, and mean value is 7.09. For the first quarter, 5.7, and median is 7. Third quarter is 8. For the y value, we have 0 observations, that's 100, and the one category we have 44 observations. Okay, first we will devise the M2 model, that's a nonlinear model. For that we use the GLM function, generalized linear function, and again, just like the linear model, we have to define this. We can use dot, that means we are trying to use all variables except y in this model. So family, we have to define the family is binomial. Then let's run it. It's very simple. Sorry, we forgot to assign the data. We have to define where the data come from. For that, this is the data set. Okay, we got the model. So let's have a summary of the model. There's the M2. Here we can find the summary. This is the just very simple linear model. Generalized linear function model. There's a binomial function. Here you can find the Davin's residues. Very firstly, you see the model. What kind of model we ran? There's y is the dependent variables, and we ran all independent variables in the data set, and is the family is binomial, and the data from this data file. This is Davian's residue. Minimum is minus 1.45, and for first quarter, median, third quarter, and the maximum. Here you can see the coefficient of estimation, that is the intercept, that's the sex2. It's the categorical variables. It is just it create one is the reference variables among the categorical variables, and it run the regression against that variables. For the age, this is the coefficient, and for educations and marital status against the 1, this is again it's similar to the sex variable. This is marital status, and the family size is that. So significance scored as usual. If you get the 3 star, you can see here how significant is your model is. So it is null deviance, residual deviance, and the AIC value. You can see here. In this way, you can run very simply the nonlinear or categorical variables. Okay, so let's see something more. This is just a logit model. We can say just this is a logit model. Okay. We can also see the confidence interval of our model. Confidence interval of our model M2. Sorry, I wrote mistake here. Confident M2. This is confident model. You can see this is it is showing some kind of error for that. Okay, now we have to define exp of coefficient of M2. I will describe what it is. Okay, this value exponential, we have exponented it to this value, and this value is a different one. See, it's different. Basically this value, from the simple running the model, this value gives the log odd. It is very difficult to explain the value as a coefficient. We cannot interpret very easily. It's a very complex thing. So instead of that, we just convert it as the exponential antilog of that coefficient. Now we can say that for the value, target value 1, if 6 is 2, I think here is a female. If there is in our observation there is a female, the likelihood of having the value 1, that's control value, will be increased by 2.04. Now it's a multiple. Likewise, age, for each year increase, the value will be multiplied, increased by this value, this time, increased by this times. Similarly, each increase in the 1 year of schooling, the value will increase by this coefficient. If the marital status is second, that is married, the likelihood will increase by 1.4 to 4 to 5 times. Likewise, increasing of the y value, that's our dependent variables, will be increased by 1.2 times if family size will increase by this increase by 1 unit. This is a general way of explaining the value, how we interpret the logistic model. It's a very simple one. I will come up with another video where I will discuss about the logit and probit. Basically, the choosing the model like the logit or probit is it is morely depends on the personal choice, because the value is much more similar, but in some cases it might be different. That's why at large we will see the very similar things. Let's plot the model at the end. This is our residual model. Now it's a little bit more, it's not very fine, very good, but it's better than the previous one. Okay, thank you very much for watching this video. I will come up with another video defining how the integrity of the logistic model or probit model. See you later. Thank you for watching. Don't forget to subscribe and like.